Hello friends, welcome to my YouTube channel 12th School Zone. இன்னைக்கு நம்ம class 12 chemistry reduced syllabus 2021-22 தான் பார்க்க போறோம். Chapter 1 இப்போ நம்ம என்னென்ன இருக்குன்னு பார்க்கலாம். Chapter 1 Metallurgy, Introduction 1.1 Occurrence of Metals, 1.1.1 Mineral and Ore, 1.2 Concentration of Ores, 1.2.1 Gravity Separation or Hydraulic Wash, 1.2.2 Froth Flotation, 1.2.3 Leaching, Cyanide Leaching, Recovery of Metal of Interest from the Complex by Reduction, Ammonia Leaching, Alkali Leaching, Acid Leaching, 1.2.4 Magnetic Separation, 1.3 Extraction of Crude Metal, 1.3.1 Conversion of ores into oxides, Roasting, Calcination, 1.3.2 Reduction of metal oxides, Smelting, Reduction by carbon, Reduction by hydrogen, Reduction by metal, Auto reduction, 1.6 refining process, 1.6.1 distillation, 1.6.2 liquefaction, 1.6.3 electrolytic refining, 1.6.4 zone refining, 1.6.5 vapor phase method, MON process for refining nickel, Van Arkel method for refining zirconium or titanium. Chapter 2 P block elements 1 Introduction 2.1 General trends and properties of P block elements, 2.1.1 Electronic configuration and oxidation state, 2.1.2 Metallic nature, 2.1.3 Ionization enthalpy, 2.1.4 Electronegativity, 2.1.5 Anomalous properties of first elements, 2.1.6 Inert pair effect, 2.1.7 Allotropism in P block elements, 2.2 Group 13 Boron group elements, 2.2.1 Occurrence, 2.2.2 Physical properties, 2.2.3 Chemical properties of boron, uses of boron, 2.2.4 borates, preparation, properties, uses of borates, 2.2.5 boric acid, preparation, properties, structure of boric acid, uses of boric acid, 2.2.9 alums, examples, preparation, properties of alums, uses of alum, 2.3 group 14 carbon group elements, 2.3.1 occurrence, 2.3.2 physical properties, 2.3.3 tendency for catenation, 2.3.4 allotropes of carbon, structure of graphite, structure of diamond, structure of fullerenes, structure of carbon nanotube, structure of graphene, 2.3.8 silicones, preparation, type of silicones, properties and uses. Chapter 3 P block elements 2 Introduction Group 15 Introduction 3.1 Group 15 nitrogen group elements, 3.1.1 occurrence, 3.1.2 physical properties, 3.1.3 nitrogen, preparation, properties of nitrogen, uses of nitrogen, 3.1.4 ammonia, preparation, properties of ammonia, chemical properties, structure of ammonia, 3.1.7 allotropic forms of phosphorus, 3.1.8 properties of phosphorus, uses of phosphorus, oxo acids of phosphorus, structure, group 16 oxygen group elements, occurrence, physical properties, 3.2 oxygen, preparation, properties, chemical properties, uses of oxygen, 3.2.1 allotropic forms of sulfur, 3.2.2 sulfur dioxide, preparation, properties, chemical properties, uses of sulfur dioxide, structure of sulfur dioxide, structure of oxo acids of sulfur, group 17 halogen, 3.3 group 17 halogen group elements, 3.3.1 chlorine, occurrence, physical properties of chlorine, 3.3.1 manufacture of chlorine, physical properties, chemical properties, uses of chlorine, 3.3.4 interhalogen compounds, properties of interhalogen compounds, structure of interhalogen compounds, 3.4 group 18 inert gases elements, 3.4.1 occurrence, physical properties, inert gases, properties of inert gases, chemical properties, structures of compounds of xenon, uses of noble gases. Chapter 4 Transition and inner transition elements, Introduction, 4.1 Position of D block elements in the periodic table, 4.2 Electronic configuration, 4.3 General trend and properties, 4.3.1 Metallic behavior, 4.3.2 Variation of atomic and ionic size, 4.3.3 Ionization enthalpy, 4.3.4 Oxidation state, 4.3.5 Standard electrode potentials of transition metals, 4.3.6 Magnetic properties, 4.3.7 catalytic properties, 4.3.8 alloy formation, 4.3.9 formation of interstitial compounds, 4.3.10 formation of complexes, 4.4 important compound of transition elements, F block elements, inner transition elements, the position of lanthanoids in the periodic table, electronic configuration of lanthanoids, oxidation state of lanthanoids, atomic and ionic radii, causes of lanthanoid contraction, consequences of lanthanoid contraction, actinoids, electronic configuration of actinoids, oxidation state of actinoids, differences between lanthanoids and actinoids. Chapter 5 Coordination Chemistry Introduction 5.1 Coordination Compounds and Double Salts 5.2 Werner's Theory of Coordination Compounds, Postulates of Werner's Theory 5.2.1 Limitations of Werner's Theory 5.3 Definition of important terms pertaining to coordination compounds 5.3.1 Coordination Entity 5.3.2 Central atom or ion 5.3.3 Ligand Coordination sphere, coordination polyhedron, coordination number, oxidation state, oxidation number. Types of complexes, classification based on the net charge of complex, classification based on kind of ligand. 5.4 Nomenclature of coordination compounds, naming the ligands, naming the central metal. More examples with names, IUPAC nomenclature. 5.6 Theories of coordination compound. 5.6.1 Valence bond theory. Main assumptions of VBT. Illustration 1 to 4 Limitations of VBT. Chapter 6 Solid state. 6 Introduction. 6.1 General characteristics of solids. 6.2 Classification of solids. 6.3 Classification of crystalline solids. 6.3.1 Ionic solids. 6.3.2 Covalent solids. 6.3.3 Molecular solids. 6.3.4 Metallic solids. 6.4 Crystal lattice and unit cell. 6.5 Primitive and non-primitive unit. 6.5.1 Primitive or simple cubic unit cell. 6.5.2 Body-centered cubic unit cell. 6.5.3 Face-centered cubic unit cell. 6.5.4 Calculations involving unit cell dimensions. 6.5.5 Calculation of density. 6.6 Packing in crystals. 6.6.1 Linear arrangement of spheres in one direction. 6.6.2 Two-dimensional close packing. 6.6.3 Simple cubic arrangement. 6.6.4 Body-centered cubic arrangement. 6.7 Imperfections in solids. 6.7.1 Schottky defect. 6.7.2 Frenkel defect. 6.7.3 Metal excess defect. 6.7.4 Metal deficiency defect. 6.7.5 Impurity defect. Chapter 7 Chemical Kinetics Introduction 7.1 Rate of chemical reaction. 7.1.1 Stoichiometry and rate of reaction. 7.1.2 Average and instantaneous rate. 7.3 Rate law and rate constant. 7.4 Molecularity. 7.5 Integrated rate equation. 7.5.1 Integrated rate law for first order pseudo first order reaction. 7.5.2 Integrated rate law for zero order reaction. 7.6 Half-life period of a reaction. 7.8 Arrhenius equation, the effect of temperature on reaction rate. Chapter 8 Ionic equilibrium Introduction. 8.1 Acids and bases. 8.1.1 Arrhenius concept. 8.1.2 Lowry-Bronsted theory. 8.1.3 Lewis concept. 8.2 Strength of acids and bases. 8.3 Ionization of water. 8.4 The pH scale. 8.4.1 Relation between pH and pOH. 8.5 Ionization of weak acids. 8.5.1 Oswald's dilution law. 8.6 Common ion effect. 8.7 Buffer solution. 8.7.1 Buffer action. 8.7.3 Henderson-Hasselbalch equation. 8.9 Solubility product. 8.9.1 Determination of solubility product from molar solubility. Chapter 9 Electrochemistry Introduction. 9.1 Conductivity of electrolytic solution. 9.1.1 Molar conductivity. 9.1.2 Equivalent conductance. 9.1.3 Factors affecting electrolytic conductance. 9.1.4 Measurement of conductivity of ionic solutions. 9.2 Variation of molar conductivity with concentration. 9.2.2 Kohlrausch law and applications. 9.3.2 Galvanic cell notation. 9.3.4 Measurement of electrode potential. 9.4 Thermodynamics of cell reactions. 9.4.1 Nernst equation. Electrolytic cell and electrolysis. Faraday's law of electrolysis. First law, second law. Electrochemical series. Chapter 10 Surface Chemistry Introduction. 10.1 Adsorption and absorption characteristics of adsorption. 10.1 Adsorption and absorption characteristics of adsorption. 10.1.1 Types of adsorption. Distinction between physical and chemical adsorption. 10.1.2 Factors affecting adsorption. 10.1.3 Adsorption, isotherms and isobars. 10.1.3.1 Freundlich adsorption theory, isotherm and limitations. 10.2 catalysis, positive and negative catalysis. 10.2.1 characteristics of catalysis, promoters and catalytic poison, autocatalysis, negative catalysis. 10.2.2 theories of catalysis, the intermediate compound formation theory, adsorption theory and active centers. 10.5 colloid, dispersion phase and dispersion medium. 10.5.1 classification of colloidal solution. 10.5.2 preparation of colloids, dispersion methods, mechanical dispersion, electrode dispersion, ultrasonic dispersion, peptidization. Second one, condensation method, oxidation, reduction, hydrolysis, double decomposition and decomposition. Third method, by exchange of solvent. 10.5.3 purification of colloids, dialysis, electrodialysis and ultrafiltration. 10.5.4 properties of colloids. 14 points: color, size, heterogeneous nature, filtrability, non-setting nature, concentration and density, diffusibility, colligative properties, shape of colloidal particles, optical, kinetic and electrical properties, coagulation, protective action. Chapter 11, hydroxy compounds and ethers. Introduction. 11.1 classification of alcohols. 11.2 IUPAC nomenclature, structure of functional group of alcohols, physical properties of alcohols, preparation of alcohols, methods to differentiate primary, secondary, tertiary. Physical properties of alcohols, chemical properties of alcohols without mechanism, uses of alcohols, acidity of alcohols, acidity of phenols, preparation of phenol, physical properties of phenol, chemical properties of phenols, test to differentiate alcohols and phenols, uses of phenol, ethers classification, structure of functional group, IUPAC system, preparation of ethers, except mechanism, physical properties, chemical properties of ethers, except mechanism and uses. Chapter 12, carbonyl compounds and carboxylic acids. Introduction. 12.1 nomenclature of aldehyde and ketones. 12.2 structure of carbonyl group. 12.3 general methods of preparation of aldehydes and ketones. 12.4 physical properties of aldehydes and ketones. 12.5 chemical properties of aldehydes and ketones, mechanism only for aldol and Cannizzaro reaction. 12.6 test for aldehydes, first two tests only. Carboxylic acids. 12.8 IUPAC nomenclature of carboxylic acid carboxyl group. 12.10 methods of preparation of carboxylic acids except serial number 5. 12.11 physical properties of carboxylic acids. 12.12 chemical properties of carboxylic acids except mechanism of esterification, test for carboxylic acids. 12.13 acidity of carboxylic acids. Chapter 13, organic nitrogen compounds. Introduction. 13.1 nitro compounds. 13.1.1 classification of nitro compounds. 13.1.2 nomenclature of nitroalkanes. 13.1.3 isomerism. 13.1.4 acidic nature of nitroalkanes. 13.1.5 preparation of nitroalkane, first three methods only. 13.1.6 preparation of nitroarenes, first method only. 13.1.7 physical properties of nitroalkanes. 13.1.8 chemical properties of nitroalkanes. Chemical properties of nitrobenzenes. 13.2 amines classification. 13.2.1 nomenclature, IUPAC system of amines. 13.2.2 structure of amines. 13.2.3 general methods of preparation of amines. 13.2.4 properties of amines. 13.2.5 chemical properties. 13.2.6 chemical properties of amines. Chapter 14, biomolecules. Introduction. 14.1 carbohydrate. 14.1.2 classification of carbohydrate. 14.1.3 glucose except cyclic structure of glucose. 14.1.4 fructose except cyclic structure of fructose. 14.1.5 disaccharides. 14.1.7 importance of carbohydrates. 14.2 proteins. 14.2.1 amino acids. 14.2.3 properties of amino acids. 14.2.4 peptide bond formation. 14.5 nucleic acids. 14.5.1 composition and structure of nucleic acid. 14.5.3 types of RNA molecules. இப்போ நம்ம தியரிக்கான ரெடியூஸ் சிலபஸ் பார்த்தோம். அடுத்து ப்ராக்டிகல்ஸ் பார்க்கலாம். ஆர்கானிக் கம்பவுண்ட்ஸில் பென்சோஃபினோன், சின்னமிக் ஆசிட், யூரியா, குளுக்கோஸ் அண்ட் அனிலீன். வால்யூமெட்ரிக் அனாலிசிஸில் ஃபர்ஸ்ட் ஒன் எஸ்டிமேஷன் ஆஃப் ஃபெரஸ் சல்ஃபேட் பெர் மேங்கனோமெட்ரி. செகண்ட் ஒன் எஸ்டிமேஷன் ஆஃப் ஃபெரஸ் அமோனியம் சல்ஃபேட் பெர் மேங்கனோமெட்ரி. Third one, estimation of oxalic acid, acid-base titration. Thank you.